Hello everyone, today's lesson will take you through the basics of physical properties. The main points of the lesson include the 4 parameters that regulate physical properties and the 2 kinds of scenes and the other factors that affect physical properties. Before the lesson, we need to know that the purpose of adjusting the physical properties is to restore the real fabric properties such as stretching, bending, friction, weight, etc. The physical properties are also a difficult point in modeling. We hope that this lesson will help you to become more proficient in adjusting the shape of the fabric and wrinkles precisely. We broke this lesson into 4 parts. First of all, stretch and bending. These 2 parameters are the most basic parameters that affect the fabric in Style3D and basically determine the performance of the fabric. Second, buckling ratio and buckling stiffness. These 2 parameters may be a little difficult for you guys to understand. When you can't get the ideal fabric performance with the help of the first 2 parameters, you can use these 2 parameters to help adjust the fabric. Third, the 2 kinds of scenes. In these 2 different scenes to adjust the stretching, bending, buckling ratio and buckling stiffness, the performance of the wrinkles is not the same. Last, other factors. Except the physical properties, the particle distance and length difference will both affect the final shape of the fabric, so we generally need to adjust the physical properties, particle distance and shrinkage ratio together to achieve the final performance we want. Okay. Firstly, stretching and bending. Let's start with the definition of these 2 parameters in Style3D. Stretching is the stretching strength of the fabric in the corresponding warp, weft, and bias directions. Higher the number, the fabric is harder to stretch. Tighter the fabric, easier to generate wrinkles in 3 directions. Lower the number, looser the fabric, easier to stretch, or it's more flexible. Bending is the bending strength of the fabric in the corresponding warp, weft, and bias directions. Higher the number, harder to bend in weft, warp, and bias directions and harder to generate the wrinkles, the fabric looks harder. Lower the number, easier to generate the wrinkles, the fabric looks softer. Now let's check it in the project to give you some explanations, because if we just talk about the theoretical knowledge, it may still be a little abstract. Okay, let's look at the fabric first. We all know that fabric is made of triangle. Simulate. Pulling this fabric, and stretching is the triangle of the edge line can be pulled to how long? Okay, we can turn down the stretch of the first fabric. The smaller the number, the weaker the stretch resistance, the easier it will be stretched. As you can see, this piece of fabric has been stretched. So let's work on the second piece of fabric. If we increase the stretch value, the less likely the fabric will be stretched. It's even going to shrink a little bit and the fabric is going to be tighter and less likely to be stretched. Okay, let's bring it back to the default. And adjust their stretch properties separately. For the first fabric, we'll adjust its weft direction stretch to 0. For the second fabric, we'll adjust its warp direction stretch to 0. For the third fabric, we'll adjust its bias direction stretch to 0. We found that the middle of the fabric, it was stretched the longest. This is also because now the fabric is mainly affected by a gravity, so the direction parallel to the gravity is its warp direction. If the stretch is to a minimum, the warp direction is more easily stretched, the fabric will be stretched longer. We should also pay attention to the fact that when we adjust the texture and turn it across, the yarn direction changes from the warp direction to the weft direction. Look that, it shrinks back. So the yarn direction of the fabric has changed and the corresponding physical properties will also change if you adjust the yarn direction. The physical properties of the fabric must be adjusted to ensure that the shape of the fabric is correct. Okay, let's look at the bending. Let's go back to the triangle. How can we understand the bending? We pull up the corner of the fabric. You can see that the fabric is folded along the edge of the triangle. The bend can be interpreted as the triangle folded up to form the angle. The smaller the value of the bending, the smaller the angle tends to be, the easier it is to be. The larger the bending value, the less likely it is to be bent, which means that the angle tends to remain at 180 degrees. We can look at what happens if the bend value becomes large. Simulate. So that the angle formed by folding up is easy to maintain at 180 degrees. Not easy to be bent. The fabric will also look very hard. Okay, let's look at the following 3 pieces of fabric. First of all, let's check their yarn direction. You can see that the yarn direction of all 3 fabrics is the same. Then, let's bend the first piece of fabric in the weft direction and pull it to the maximum. The second piece of fabric is bent in the warp direction and pulled to the maximum value. And the third piece of fabric is bent in the bias direction and pulled to the maximum. Okay, let's simulate. They stand up in different directions, so let's observe. The first piece of fabric, the direction of its support is perpendicular to the direction of its yarn, that is, the weft direction. Is it supported? It's because I just pulled the bending value of the weft up to the maximum, that is, it's not easy to be bent in the weft direction, and the final performance is like this. The second fabric is supported parallel to the direction of the grain lines. It is supported parallel to the direction of the warp. That is also because I have just adjusted the warp bend to the maximum, so it is not easy to bend in the warp direction. The third piece of fabric, as you can see, is supported along the diagonal, which corresponds to what I just did. Okay, this is the effect of bending in different yarn directions. Let's simulate the effect of bending in different yarn directions on the garment. Take the yarn direction that we just adjusted to horizontal and adjust it back again. And then make sure that the yarn direction of the 3 pieces of fabric is now the same. Let's adjust the bend of the first fabric weft direction to the maximum. And then open the bend of the second fabric warp direction to the maximum. The bend of the third piece of fabric bias direction up to the maximum. Okay. Simulate it and see that the fabric is prop up in different directions. The operation just now was to adjust the bending value in the weft direction to the maximum, so now it is also along the weft direction to support. The second fabric, the operation was to adjust the bending value in the warp direction to the maximum, and now it is supported in the warp direction. The third fabric, the operation was to adjust the bending value in the bias direction to the maximum, and it was supported in the diagonal direction. We know that when we adjust the bending value of different yarns, it will have different effects on the appearance of the garment. For example, if we need to make a fluffy skirt, we can adjust the bending value in the bias direction or in the weft direction. If we need to keep the skirt drapey, we don't need to adjust the bending value in the weft or bias direction. Let's go back to the PPT to see the effect of stretch and bend on the body of the garment. Minimize the stretch value, the garment will be more likely to be pulled apart and deformed. Think about our usual modal clothing. And adjust the stretch value to the maximum, and the garment is less likely to be stretched. It will also be the body's joints or undulation point to generate more wrinkles. If the bending value is set to the minimum, the garment will generate more fragmented and more wrinkles, and if the bending value is set to the maximum, the garment will be less likely to be bent, and the garment will tend to be flatter. The second is the buckling ratio and buckling stiffness. Note that these two need to be used together, adjusting only one of them has no effect. After adjusting the stretching and bending, if you feel that the garment still can't achieve the desired performance, you can also adjust buckling ratio and buckling stiffness to refine some of the wrinkles. Buckling ratio is used to control the amount of wrinkles that can be identified in the warp, weft, and bias direction. Higher the number, easier mesh is taken as wrinkle in weft warp bias, and the more wrinkles can be refined. For example, if we set the buckling ratio to 30, then the area that can be recognized to form wrinkles is 30%. If we set the buckling ratio to 90, then the area that can be recognized to form wrinkles is 90%. After the wrinkles area is identified, how to form the wrinkles? Buckling stiffness can control the degree of refinement of the identified wrinkles in the weft, warp, and bias direction. The value represents the percentage change of the bending value at the wrinkles. Here is the formula. Final bending value at the wrinkles equal to original bending multiplied by deformation strength. That is, if the original bend value is 30, and buckling stiffness is also 30, then it is 30 by 30%. 30 multiplied by 0.3 equal to 9. Well, the bending value is definitely smaller. The smaller the bending value, the easier the fabric will be bent. The bending value is smaller, the fabric will be more likely to be bent and generate more wrinkles. The greater the value of buckling stiffness, the greater the final bending value of the identified area, the smoother the turn, the harder the fabric. The smaller the buckling stiffness value, the smaller the final adjustable bend value at the wrinkles, the larger the turn, the sharper and finer the wrinkles, and the softer the fabric. And now that we know the buckling ratio and buckling stiffness, what can we apply them to? Imagine those polyester shirts, sun protective clothing and down jackets. Their silhouette is relatively rigid and broad, but the fabric has small and trivial wrinkles. If you directly adjust the bending value to very small, the garment or fabric may immediately collapse. The recommended approach is to adjust the buckling ratio and buckling stiffness to adjust the wrinkles and the degree of delicacy. And to ensure both the stiffness of the silhouette and the finesse of the wrinkles, these two parameters are very useful. Next, let's talk about a little trick to adjust these two parameters, for example, like knitted fabrics. The wrinkles are more rounded, as you can recall, so it is not that necessary to adjust the buckling ratio and buckling stiffness. But woven fabrics are different, the wrinkles are sharper, so the buckling ratio and buckling stiffness usually need to be adjusted to control the sharpness and the size of wrinkles. Okay, and the third part of the two scenes. The first point is affected by self-weight and gravity. This should be easy to understand. The weight of the clothing when adjusted to 2000, it looks longer than when the weight is adjusted to 300. Okay. Let's look at the top 3 pieces of fabric. First, we set their physical properties to default and let them sag naturally. Then, at the bottom of the physical properties, I set the second fabric to have a weight adjusted to 2000, and then simulate it. The fabric will drape more than the original one, and it will stretch longer. The second aspect is that the shape of the fabric and the garment will be affected by the other clothes pieces, the sewing line and the model. For example, a down garment will be pulled by the quilting line and the wrinkles will be distributed on both sides of the quilting line. In addition, for garments with a knotted structure, the wrinkles will be distributed around the knot. Okay, these are the two scenes that affect the shape of the fabric. And then we'll talk about the fourth part, which is the other factors that affect the shape of the fabric. The first part is about the particle distance. The smaller the particle distance, the more delicate the wrinkles are simulated. In the first picture, when the particle distance is 50, the triangle is too big, and there is not enough turning space for it to form undulating wrinkles. When the particle distance is 5, the triangle is very small, and it has enough room to turn to form these undulating wrinkles. The second point is the shrinkage ratio and the length difference. When the length difference is bigger, the more wrinkles will be produced. For example, this half skirt on the left, its length is 272 centimeters. On the right it is only 119 centimeters. So, obviously, the length difference on the left is greater, and the length difference on the right is smaller. But when you look at the bottom hem, you can see that the amount of wrinkles here is obviously greater than the pleats on the right. This reflects the impact of the length difference of the fabric on the shape of the garment or the shape of the wrinkles. Finally, among other factors, there is also the dynamic friction and static friction. Let's look at the project. Let's open the style line. Now you can see that one piece of fabric is frozen on this slant and the other piece of fabric is free to move. Click on the fabric and see the last line, dynamic friction and static friction. Static friction is the coefficient of friction when it is stationary, and dynamic friction is the coefficient of friction when the fabric is moving. And when the static friction is turned up to the maximum. Simulate. The fabric stays still. Because this is the same piece of fabric, the friction between them has reached the maximum, so they all tend to stay still. Pulling up also can feel the friction is very large. And what is the dynamic friction? At this time, if we turn on the dynamic friction to the minimum, it will be very silky. And the fabric is sliding very fast. If we turn on the coefficient of friction to the maximum, it will move very slowly. It is to control the speed of its decline in the case of inevitable movement. That is dynamic friction and static friction. If this is reflected in the garment, sometimes when we make this knot, we maybe use these two parameters. For example, if we minimize the static friction of the default fabric and simulate the knot, it will slowly slide off. If we turn down the dynamic friction together, it will slide faster. But if we increase the static friction at this point, it will stay in the same state. Okay, so here are the parameters and factors that affect the physical properties have been explained. I will explain the application of physical properties in the next video, and welcome you to give a like and share the video. We will reply to all the key questions in the comments section, and we will see you in the next video.